YouTube takes some time. Okay, perfect. So, good afternoon, dear viewers. Let's see how the stream will go. I have something like 1.5 hours before we have some architecture call with Magento concerning this fix. So I hope to fix a small issue I have right now with cache functionality here. So I hope I can really do some numbers already before the call. If not, yeah, I would have to do it later, but anyway, I'm gonna start with this fix. So basically what I'm planning to do here is take the Magento config functionality and in the places where Magento config cache is actually flashed, I want to make sure that the stale config module of Magento, so this is the part where Magento application config is generated. We have here a config type system. This config type system receives a cache instance of frontend interface. This one is actually defined in DI XML. Here you can see that it uses the classes Magento framework app cache type config, and here we see that it actually uses some extends from text scope in order to provide a functionality for the front-end cache flushing for all the entries that have this config cache tag in. The problem is that I have right now is that this config type, I was implementing here some functionality that loads the stale data when the cache is not available, right? So it tries to load this stale data, and then if the stale data is available for the current scope, it's gonna return it. So we don't need to regenerate cache all the time actually to regenerate the cache data without storing it into the cache system. So but this one is never invoked in my performance test I was running, because I found out, like, yeah, I'm still using the same caching model here. So I'm using the same cache load, the same one that is used as a dependency, and this yeah, wait a second, where it is. I think it's type config, yeah. So this one. So it's using this type config cache model that automatically appends this cache tag type config. And when I actually flush the cache, it actually flushes all the cache, including my stale content. So what is the basic idea I plan to implement? The basic idea I plan to implement is to take this class, write a plugin around it that will intercept calls to save function, and actually not a save function, sorry, to the clean function. And inside of this clean function, if we receive this cache clean mode all as an argument, then what we're gonna do, we're gonna make sure that oh, actually we can do it for all of them, because it also clean mode matching tag. Oh yeah, I see what it does. Yeah, so it's not a big problem. Okay, this one I can leave out. So what I see here, for instance, that when we have this clean operation happening, and when we supply some data here, it will clean all the records that have this cache tag, and this cache tag is already appended to every single record that is stored by this system config model. So what I'm gonna do, I'm gonna take this cache tag. Oh, sorry, I'm just gonna write an around plugin around the clean method. And when I'm gonna write this around plugin for the clean method, before cleaning it with the overridden plugin, I'm gonna load the cache data for stale cache, and after cleaning, I'm gonna right away actually save the cache data after cleaning. So on the next call to loading the data that is not there, and on the next generation when the cache gonna be locked, the cache data will be already available there. But I run into a small issue because I can't easily test it out without overriding a lot of stuff, so, and without actually instantiating a lot of dependencies in order to instantiate this cache frontend model. So what I'm gonna do, I'm gonna write an in-memory cache implementation in order to make my testing easier, because right now it's a little bit complicated to do. So I was trying to start doing it, and then I run into a problem. Hey, how do I instantiate this front-end interface instance without doing a lot of functionality around instantiating those objects. So what I'm gonna do, I'm gonna actually go into the folder where this front-end interface is implemented, and here we see there is a couple of front-end interfaces. There are some decorators around it, of course. There is some adapters, important for me. So I'm gonna implement the test method, the load method, and the save method. So what I'm gonna do here, I'm gonna first of all create a test case. I think it's in front-end, yeah, adapter, and I'm gonna create a test case called in memory test. Okay, test. Yeah, so in memory it's going to be our adapter. It's actually quite good actually to not to call those adapters fakes or stubs, because in the end in memory test can be used as a replacement, and let's say if you are working with also some asynchronous applications, you can then port the code that is using this front-end interface into the asynchronous HTTP application, and then in memory caching adapter makes sense because you have a single-threaded process that runs long-term, and you don't want to involve any EO in order to cache something. You just want to cache it inside of memory of your current application. So let's see how easy it's gonna be to implement. So yeah, let's go. Let's implement this front-end interface. Oh, sorry, not the right thing. Oh, my command key doesn't work on this Mac. Okay, I actually wanted to extend from test case. Right here we go. And let's see. So now I'm gonna write a test case that it will return false, right, if we do test for something that doesn't exist. So first of all, we want to create some kind of test case that is very simple, that it doesn't do any actual functionality. it just tests the default state of the service we are gonna write. So the default state gonna be that we don't have anything in the cache. So what we're gonna test first, that testing for cache availability results in false when storage is empty. So this is going to be our first failing test case. So right away I think we're gonna create a setup method, because I don't want to rewrite it later. I know there's gonna be a lot of different test cases. So this front end, so this is gonna be a front end cache model, so it will be in memory. And here we're gonna create a new in memory caching adapter. So let's go on and actually create the class. Oh, it doesn't let me to create it like this. Okay, so let's go on and create the class here then. In memory. This is actually something that I don't understand from Magento naming convention, because, like, yeah, I understand we have an adapter here as a directory, but they don't put a suffix to the class letting you know when you actually request this class what is actually gonna happen, because I think it's much more convenient when you start to request some class as a dependency to understand what class it is. Because right now, if for instance I start to use let's say what we have as an example, for instance adapter, yeah, so as you see there's so many different adapters, and I need actually to read through all of them in order to find out which one actually I want, because I don't have a suffix like, is it adapter for translation, is it adapter for payment method, or also adapter is very generic name in my opinion. Let's say something different. Let's say I want to have what I have in Magento that I was using a lot, but it was having too much of possibilities. I think like source. Yeah, so here for example we see a source being used so much without distinguishing what kind of source it is, what it's related to, because yeah, it's a little complicated. And for instance yeah, here I have to follow the same naming practice, because it would be strange if I would name it in memory, let's say adapter, or let's say cache, in memory cache adapter, right? It would be not in line with Magento naming standard, and then my pull request will never pass a code review. So I have to follow it in the same way as they write. Okay, so now I can actually import the class, and this is gonna be this cache frontend in memory. So this is gonna be our adapter that we're gonna test. And actually, sorry, it's not an adapter, it's actually a frontend, but here it's named adapter. So now I'm gonna do a small thing here. Yeah, I have actually to implement here a frontend interface, and just create an empty stub. Right, we see there's a lot of stuff going on. And here I'm just gonna put some calls, let's say to test, right? Test that some value is in cache. So I'm gonna test that, let's say, system, or let's say the cache key, let's say 1, and I'm gonna test that this cache key actually returns me false, because I know that I didn't put anything into the cache so far, so this value must be same as false, and I expect this test actually gonna fail. Let's see. Yeah, failed, asserting that null is identical to false. And right away I'm actually gonna run the whole class, and I'm gonna put it into the after run mode. So now I can go here and I can just fake my implementation just to put it like this. So the test is now green. Also I will put the after test delay to 1 second, because I like to do it in a more automated way. Okay, so this test case passes. Now let's create another test case. Let's call it when cache is saved, testing for its availability, returns true, right? So now we wanna assert that it's gonna return true if this frontend test, let's say cache key 1, right? What we're gonna test? We're gonna test that the test cache key 1 is gonna equal to true. So here we're gonna use this frontend, and we're gonna invoke some save operation. We're gonna save some data into the cache key 1. Right, looks good in my opinion. And here we have a failing test, because yeah, true is not equals false, so it's quite reasonable. So now you see we have now a behavior being tested. It's actually very important when you write a test. You don't test just a method itself, you test the behavior of the method. And sometimes the behavior of the method is not related only to this method, it's related to the chain of events that result in the behavior. So here you see that I have the setup phase of my test that saves some data to cache, and then I invoke the exercise of the caching model in order to test if this cache key is over there. So here we see that when cache is saved, testing for its availability returns true, so it's specific behavior that I'm testing here. So now let's go on here. As you see, yeah, I'm not gonna change anything here for now. I'm just gonna change something here, and as we are doing it in TDD manner, we're just gonna say that, let's say, data is gonna be true, and here we're just gonna test if this data, we're gonna return true, right? Or even we can do something like this. We can just check this data, otherwise it's gonna be false. So it's even simpler, and we're gonna also define the data here, and let's see, yeah, now it's actually green. So I'm stopping right here, and I'm gonna go into the next test. now I'm gonna write a test case for another use case. Let's say when unrelated cache is saved, only requested test validation returns test requested cache key test validation returns returns result. So if, let's say, unrelated, yeah, this is better name. Okay, and here I'm gonna test that assert same false, because I know that let's say this front end test cache key 1, all right, that it's gonna return me false. And at the same time, here I'm gonna save some data again into the cache key, but this time 2. So you see I'm saving an identifier for the wrong cache key, and I expect it will return false, because I followed the basic rule of TDD that you don't write the code that you don't need for making your test pass. You see that my next test case is actually failing, so I can actually implement now a logic where I have multiple cache keys being stored in the cache backend. So now what I can do, I can now change actually this data into an array, and here I can test that this identifier is available here, and I can replace this one into simple is set. So if we have let's say data being set here, then we're gonna return true, and here for instance I can just replace this one with this identifier true. So now all my tests are green, functionality is working as expected, and now I can go directly into implementing another test case. So we're gonna go further on, we're gonna go and implement other test cases. So let's see what's going on here. So when related, I think we can just continue with this one. Let's see what I wanted to test. Oh, now I actually want to test that I can actually load the data that I've saved. So saved data can be retrieved. Oh no, my missing command key on my Mac makes me really bad at typing stuff, because yeah, I just occasionally click on it and it doesn't work, and then some pop-ups coming up that I didn't expect to press. Okay, so now we have saved data can be retrieved from what? Can be retrieved after it was saved. Okay, so actually saved data can be retrieved by loading it by with a cache key, right? So let's see, this front end save, let's say data1, just to make sure that we provide some different data than we was providing before. Then we specify cache key, let's do it 1, and then we're gonna assert that we receive this data1, and this front end say load, right? Load cache key 1, right? So this is our data, and we see, yeah, so now it's failing because the load method returns us what? It returns us no, right? So as we see actually here that the data is always a string, so yeah, strange we don't have it defined as a type of the argument, but it's okay. So here we have cache key is 1 and data 1. Okay, so here now I need to go on and let's say change the implementation here, and here let's say I wanna do some logic here. So then I'm gonna return this data identifier. So very simple test case. Yeah, I just make it pass. So let's go on and implement another test case. Another test case is gonna be let's say, let's create some kind of failure scenario. So when data was not saved, loading it returns false, right? So when we load the data that is not there, Magento needs just to return us false. So we're gonna preserve this behavior. So we're gonna expect that this frontend load of cache key 2 gonna return us false, but we see that it's actually an error. So what I'm gonna do here, I'm just going on, but it's also you know, like it's only useful for either testing or actually writing an asynchronous applications that can run as standalone HTTP server or socket server and then just access its own memory storage. Okay, so let's see what I have here. I have here this one working, this one working. I don't store actually stuff called tags, right? So we will come to this one, I think, later. Okay, so here we have also identifier itself as well, right? But so what we can do, we can write a test case spec removing cache removing cache let's say removed cache entry results in false during load, right? So let's do the same. False, this load cache key frontend cache key 1, and here in order to reproduce this failure scenario, then I need to do what? I need to first, of course, save this one. So let's say we're gonna have data 1 being saved as cache key 1, right? So here we have fail asserting that data 1 is identical to false. So our test case fails, but I also didn't execute yet this remove operation. So remove operation is data 1. Oh, sorry, not data 1, cache key 1. So it should actually remove an entry. Now I have a failing test, so now I can go on into this remove method and I can actually implement it. In PHP, you don't need to validate the key existence when you remove a data from a hash map. So you just can unset this one and it will just work. It doesn't matter if it's there or not. So I even don't need a test case for this one. I can just leave it like this. So now I'm gonna go into another test case, and another test case is gonna be a little bit more complex because as we see here, what I don't have yet implemented in this in-memory test case, I didn't implement yet the clean method. Also about these ones, I think what I will do, I will actually put here just throws some not implemented exception, because I don't think I need to implement this low-level front-end or back-end in order to do this for my current task. And I don't want to have any code that actually utilizing the caching front-end accessing this internal implementation details that just leak here. It doesn't sound like a good option in my opinion. So here we have another test case, and another test case is gonna be called clears all cache, right? So let's say we do some save data1 cache key 2 this front end save data 2 cache key 1, or actually let's change them 1 and 2 so to be consistent. And then here what we're gonna do, we're gonna just assert that the result is gonna be false. So you will notice why actually I'm doing it. I want to have a single assertion per test case. So let's say here when I call the front end clean, I'm actually cleaning all the cache entries. So I want to make sure that every single call to this entries should result in empty cache. So here what I'm gonna do, I'm just gonna do this front end load cache key 1, and then this front end load cache key 2. So I want to make sure that all the assertion is evaluated, and if test fails, I don't need to rerun my test to understand what is the reason for failure. So I can already see all the data that is related to my assertion being shown. If I would have multiple statements here, it would be much more harder for me to read it just from the testing output what actually happened. And also here I'm just gonna add a comment, tell that clearing cache has failed, key data is returned. Okay, so now clean cache has failed, it is returned as saved, so we have a failure message, and now we just can go on and modify our clean method. What I will do here, I'm just gonna set this data to an empty array. So I think it's more than enough in my opinion. So what I'm gonna do now, I'm gonna implement another one, right? So we're gonna go with this test case, and now I'm actually gonna add some caching tags, right? So let's say when I clear cache by tag, only tag records are removed, right? So this is very simple, I think, to implement. So what we will do here, data with tag 1, data 2, okay, cache key 1, and here we'll specify tag 1. So this will be the record that we're planning to remove. Here we're gonna clean. Here we're gonna use this terrible thing like the constant. So what we'll do here, we will do matching tag functionality, and we're gonna specify an array of tags, right? So the tag we're gonna specify is tag 1. Okay, looks good in my opinion. Also, I don't like this leak of the actual implementation details. So I'm gonna put here some constants that's gonna be used in my test case. I will call it clean matching tag, and here I'm actually gonna put this Zend cache clean mode matching tag. So in this case, my test case is not gonna be dependent on that one. Also, actually, I can put here also all and clean matching all. Then I can replace this default. Oh wait, I'm doing it in test case. No, I don't want to do it in the test case. I want to do it here. I want to do it in my actual implementation, and here I want to replace this with self clean all. So this is a default argument. Okay, and what I wanted to do here, I also wanted to change the test case to use this front end clean matching tag. By the way, if you didn't know, in PHP it's possible to reference constants through class members, so you don't need to specify the full class name. It makes it much more nicer, in my opinion, for code simplicity. Okay, so this front end clean matching tag. Okay, it looks good. Then what we do here, yeah, I didn't actually implement yet an assertion. It just passes, so the test is green. It means it's not complete. Let's go on, and here we're gonna do some actual load validation. So I'm gonna copy this over, clear cache by tag removed unrelated record. So this is gonna be my failure because I expect it will fail with this one. So I have cache key 1 and cache key 2. I expect that only cache key 2 is gonna be returned with the data. So here we do this one. Yeah, so as I expected, it failed. Yes, because our clean is doing it just too much. So here, for instance, we have this one, and if let's say, actually what we can do, if mode is not equal self clean all, then we actually return. So this is the default behavior, right? Also, I'm gonna just inherit doc everywhere because I don't want to define my own doc comments for these methods. Where I will define them is only in places where my behavior differs from the implementation details of the method. So let's say here we have clear cache tag only, clear cache by tag only tagged records are removed. Okay, so here we have a failing case because now I return everything. Or actually I can just put here clean machine tag. So here I'm gonna go through this data by tag, I think. Oh, actually I didn't store the tag, right? So now, yes, I have to actually go in here and I will specify here data tags, this identifier tags, right? So we store this one as a property and we're gonna add a field into the class and we will specify it as an array as well. And here we're gonna specify that it's gonna be an array of strings, and actually data as well is gonna be just an array of single string, and here's gonna be multidimensional because the tags are array of strings and the data tags is actually an array of arrays of strings. So let's go on further on. So here we're gonna go for each through this data tags, right? Did I store it? Yeah. As identifier, and here we're gonna have our tags. And what I will do, I will just check if this actually if tags, okay, let's put it with a different name. If tags equal to enter tags, we're just gonna unset this data and data tags to remove this entry, right? So it should be passing now, right? And I see already, yes, so I can finish my implementation. As you see, this one works pretty well in my opinion. So it matches directly by an entry in data tags. Looks very good. Okay, let's go further on. Let's then create a spec. Clearing by multiple tags does not remove partially matching records. So this is another behavior we have in Magento. So let's say if we have tag 1 and I, let's say, will clear the tag by tag 1 and let's say tag 2, right? So then only these records should be removed. Only the records matching the tag 1 should be removed, right? Actually, wait a second, this one is a little bit more complex. Yeah, so I need to do it a little bit differently. Clearing clearing records that have multiple tags. Clearing by tags removes also records that have multiple tags matching ones provided in clearing request. Clearing by tags removes records. with multiple tags matching once in request. So yeah, it's better test name, I think. Now I'm gonna actually right away I'm gonna just write an assertion. So here I'm gonna create something like record 3 and also record 4, right? And I'm gonna expect that there's, let's say, data 3 and data 2 only removed, or actually are preserved, and the first and last record are gonna be the ones that we will match. So here then we create a front end save data 1 cache key 1. The tag will be tag 1 unrelated tag, and then tag 4. So I'm gonna make sure that both of them have cache key 4 as well, gonna have the same tags, right? Then what we have here, also I think I will switch it with places, so I want to make sure that also the case where the tag is not in the same order, it also will clean it. And then we have data 4, let's say, and cache key, oh yeah, here cache key with data 2 and cache key 2, and here we're gonna have some unrelated tag, right? And we also want to make sure that the cache key, let's say 3, with data 3 will have, let's say, only tag 4. So it means like if it clears this cache key 3 record, it also will be a failure because it shouldn't. Okay, so now it doesn't clean anything because I didn't call yet the clear by tag. And now clean, and now I'm gonna specify this front end clean matching tag, and here I'm gonna call what I'm gonna call here. I'm gonna call here the array of tags, so I'm gonna call tag 1 and tag 4. So only records that have both of those tags should be cleared, right? Okay, and the test case is failing because none of the cache has been cleared. Yeah, it's clear because I just put it here, check like this. So now I'm gonna run array intersect of entry tags, and actual tags that I'm gonna clear are gonna be tags are gonna be actually equal to the tags. Probably it's not gonna work because I know that intersect preserves, I think, keys, right? Yeah, because the intersection of these two arrays are not the same. So what I need to do, I just need to count that number of records in both arrays is actually equal, right? Now it works. Okay, and it works pretty well, I think. Okay, let's create another test case. I will call it clearing cache by tags with empty text request does not clear any records. So this is, I know, is going to be a failing test case. So I expect that every single of them actually is preserved. I'm going to remove everything that is unrelated here. So I'm gonna remove this saves because I don't want to have tests that is too long. And here I'm just gonna specify an empty array of tags, and we see that it actually cleared everything. So this one needs also to have a small thing here as well. I need to make sure that the tags that are in request are also not empty. Okay, so it looks good and it looks working. So I think I have almost working functionality here. Let's go further on. Let's see what you guys are writing. Oh, you don't write anything. Okay, so let's go further on. Okay, let's go. Let's go with further implementation. So I have the clean matching tag. It's one of the things that are used in Magento a lot. Let's see what else do we have. We have also the text scope. So clean in mode all, clean matching tag, and there's also clean matching any tag, right? Okay, so this is another test case that we have to write, and then I think my in-memory cache adapter is going to be actually complete, replicating the standard behavior of the cache functionality. So let's say, where is our in-memory test? Here we're going to create another test case, and we're going to say clearing cache by any tag, removes records that contain at least one of the matched tags, right? So this is very interesting thing, right? So we have clearing cache by any tag removes records that contain at least one of the matching tags. This looks great in my opinion as a test name. And now we can stuff. We saved data 1, data 2, data 3. We have tag 1, unrelated tag, tag 4, tag 1. So we see that, for instance, here I want to test that actually it removes everything that contains tag 4. So the tag 4 is set also on cache key 3. So here I'm gonna expect that this one gonna be removed too. And then here I will specify clean matching any tag. So I need also to specify this constant here, mode matching any tag, right? Does it work now? Yeah, clean matching any tag. And I'm gonna remove, actually what I'm gonna add here, I also gonna add here I think I'm gonna I think another record, right? Data 5, and the 5 is gonna contain this tag 1 as well, because I wanna test cases where I have all of them. And here I'm gonna add another one, and don't forget to change the key name, and data 5 must be not returned 2. So let's see. Yeah, it should be all false, but now Oh, now it's actually all false because this one works like this. Okay, so what I think actually we need to change an order a little bit, and we need to put a mode. If mode is self clean all, then we just clear the data and we return early, right? Then if it's clean matching tag, okay, actually all the rest of the cases are related to the clean matching tag. So I'm just gonna do something like this. So now we see that the case when we match any tag is looking different. So you see we actually inverted the condition. Now it's a little bit different. So now I'm gonna actually move this one into matched tags, right? So I'm gonna call this array intersect matched tags into variable, and here I'm gonna specify match tags count of matched tags is equals to count of tags. Okay, so this is still leaves this test cases green. So now I can go on and I can create a condition for matching any tag. So what I can do here, I can create the condition so is tag matched, and here I can actually do condition if mode equals to self matching tag, right? We're gonna set as matched is tag matched like this. Otherwise it's just gonna be matched tags more than one, or more than zero actually, right? So we're just gonna create something like this, and here actually we can also add something like this. We don't need this tags check, and then we can validate later on if the tags are matched, if they're matching or not. So here we see that I actually just restrict the clean matching tag to make sure that the number of matched tags is completely equal to the clean matching tag option, right? Oh, actually here is a little bit wrong thing. Here it should be, I think, is tag matched, right? So we add this kind of a condition, and now we have they just throw an error because it shouldn't happen at all that I call on this in memory front end any of those methods. So I'm just gonna make like throws not implemented exception or error when backend is accessed. So we will see right away if something is happening. So what we expect that it throws an exception class is not okay. Do we have some kind of runtime exception already in Magento for this? I don't think so. Okay. Okay, let's use a standard PHP runtime exception. Oh, actually, not the throw exception, but expect exception. And then we need to expect exception message. And exception message that we will expect. Let's first find the method get backend. Let's say get backend is not supported by this cache frontend, by not this but by in memory cache frontend. So we need to make sure that we just throw an exception if something is calling this get backend method. So now we're gonna just throw new exception, and we just gonna copy paste the message. Right, and here what I will do, I will just mark it as this method actually throws something. Oh, actually, wait, Magento framework has runtime exception. Oh, wait, yeah. Magento has a runtime exception, but it's localized. Come on. No way. No, it's not gonna happen. I'm not gonna use this one because I don't want to translate a message that actually happens on a system level in a framework. Yeah, I just gonna throw a regular runtime exception. Let's just remove this use statement here. So it throws runtime exception, and what we'll put here, this cache frontend does not have any backend, as it is a simple in memory implementation, right? Okay, this looks good. And then what we will have here, this cache frontend doesn't have any low level frontend, as it is a simple in-memory implementation. So it's also true. And what we will have here, we're gonna have another test case. So just test that that method also throws something. So throws not implemented, or actually not supported. Not supported error when low level frontend is accessed. Get low level frontend, right? Is it the one? Okay, this is the one. get low level frontend. Okay, let's see if it throws that message. No, it doesn't, so let's add throw new runtime exception with this message. Let's see. Okay, now our test case actually passing, and we can actually use this in memory frontend finally in our test case related to the configuration. So let's see, I have half an hour till the meeting, but I don't think I will have enough time to actually finish it. So let's see what we have further on. We have this stale cache plugin test. So yeah, what was the basic idea of this one? That here I'm gonna just pass as an argument a simple instance of that class. Yeah, let's see. Let's see, can I actually somehow... Oh yeah, so it's around the stale config cache plugin test. So what I'm gonna do here, actually I'm gonna make sure that some stuff gets saved. Yeah, now I remember why I was creating this one. The in-memory implementation, because I wanted to create just a front end that I'm gonna use in this plugin as an argument. So let's see. Okay, let me remember what is this signature for round plugin. Let's see. Let's open some plugins that is already here. Plugin, system message, let's say admin notification after get data. So, but I want to take a look at around plugin. I think something like this should have... No. Let's see, product type after get options array. Yeah, so this is the subject. Yeah, I see this one, but I want to take a look at around. Here it is. Let's say around delete. So we have product resource as an argument, then we have proceed, and then we have an abstract model. So abstract model, it's an argument that is passed into this one. Yeah, so proceed receives product. Okay, yeah, so it's clear. So what we're gonna do, we're gonna test that clean cache stores stale content, right? Stale cache entry again, right? This is gonna be it. Here I'm gonna create an entry setup that this plugin, right? Is a new stale config cache plugin that we are gonna create as a class inside here. So app cache stale config cache plugin, right? This is the name? Yes, this is the name. So this is our plugin, all right. So now let's add a field and let's import the class. And here I expect that plugin will have around. What method do we have implemented here in memory implementation? It's called clean, right? So it's going to be around clean, and an argument here, the first one is going to be our in-memory cache, so it will be new in-memory front-end cache adapter, right? Actually, you know what? I just can't resist naming it correctly. Let's call it memory cache. I just like it so much, more than just front end. Okay. Well, this one we're gonna remove. But the rest is actually gonna work well, I think. Yeah, the rest is gonna be easy refactorable. Let's just rerun the test. And let's rename our test case as well in memory cache test. Yeah. Come on, why would I refactor the test cases out? Yeah, it doesn't make sense. Okay, let's see what else do I have. Memory cache, right? This is here, and then we have what? We have stale config cache plugin test. So this is gonna be it. So around clean, then we pass this cache as an argument. Then what we have as well, we have also the type, let's say we call it the mode, and let's make it this cache clean all, right? And then what we'll have here, cleaning actually all cache. So let's make it clear here. Around clean, so what we have is then around clean, and here we're gonna put something like tags, right? So it's gonna be just an empty array of tags. Okay, let's see if we can run this test. Okay, call to undefined function. It's pretty clear because so this is the mode, in memory cache. No, this is not what I want to have. I want to have cache front-end interface defined here, because I want to be my plugin actually flexible. So style config cache plugin, this is it. Now I also want to simplify fully qualified name, right? Let's put string mode, and here this one is actually a tags, right? Okay, it's green because, yeah, I didn't write anything, so this cache. And what I want also to specify here for style cache config, as an argument, I wanted to provide the style cache key. So this is gonna be a cache key I'm gonna use here. So let's create a function construct, and let's put here cache key, style cache key. So this is the one that we're gonna reinitialize when we cleaning everything. And here we also gonna put something like what did I wanted to, oh yeah, so I wanted to then write actually as a test for this one. So okay, so we put here a cache key, then we're gonna specify that we actually have this stale cache key with some stale data, right? Oh yeah, I actually forgot to use here a callback. This function gonna be this cache save, right? Oh, actually clean. With mode and tags, and here's gonna be mode and tags, right? So this is gonna be our proceed function. Let's extract it, proceed, right? So this is gonna be our around plugin, around cache clean. Okay, and here we're gonna save this one as stale cache key. Do we need to put any other data? No, I don't think so. I just want to make sure that I can access this one. So then I have the round clean, it receives this one, validate. Oh, actually I just want to make sure that all the cache is cleared, so let's put something like cache key, and then I'm gonna just validate that assert same, that it actually preserves our stale data. So this is the most important one. And then the data one is actually should be false, and then I'm gonna invoke this cache load stale cache key, and this cache load cache key. So this is it, I think. This is something that I have here. Okay, so let's see. We have two arguments being passed around method. Okay, so we have around clean. This is, I think, is good something to fix, so we have to pass here closure. Actually, I don't think I need to use the same way as it's done over there. I just can use a callable proceed. I don't need to use closure specifically. So let's see. Okay, so now I see it's failing because it still returns me all the data. So I'm just gonna call proceed with mode and tags that I received. Right, good. Cleaning all cache. Yeah, so now I have a failing test case. Now what I can do before I call something, I'm just gonna use the cache in order to load this stale cache key, right? And then I'm gonna use cache save this stale data as this stale cache key, right? Wow, it's great. It's green and it's nice. Yeah, it's green, so probably I even could just put it into the system, configure it properly, and yeah, then we can just run a load test and see how it goes on. Do I need to create any other test case? I think so. I think I want to make sure that when no stale data available, no stale cache key is saved. So if, let's say, we don't have any stale cache data available, let's say we just clean something, it's completely clean cache, we need to make sure that it returns, I think, false when this cache test for this stale cache key. It just tests that there is nothing in there. Let's see. Oh, I need to run the whole test case. Yes, so the test is red as I expected because I didn't put any checks there. So let's say if stale data does not equal to false, then we actually gonna save this one. So as we see, we have actually complete implementation, in my opinion, that should work very well with the implementation. And now we can go on and add some DI plugins for this one. Let's see, do we have some plugins section here? So I will put it together with the other ones now. Okay. So we can, I think, specify it somewhere. Oh, I forgot how to do it. It's interesting. Okay, never mind, guys. I think in 8 minutes there is an architecture call that I have to attend. So it was nice streaming today. Hope you learned something from it. And till the next time, bye bye, everyone.